Building a plane that can take off and land vertically has proved to be one of the most difficult challenges in aviation history. These machines defy gravity. But for the test pilots, they were the ultimate challenge. The Harrier, the only vertical takeoff and landing jet plane in the world. Like a huge bird of prey, it can hover in midair. Only the best can fly them.
The first time I hovered in a Harrier, I would have sworn on a stack of Bibles that I was hanging from a crane because it just felt so foreign to be, 50 feet above the ground, looking all around and not moving.
The Harrier can land on an area no bigger than a tennis court. This unique airplane was designed to take off and land without a runway. The Harrier combines the best of planes and helicopters. Helicopters can take off and land anywhere, but they can't fly very fast. The current world airspeed record, held by a Lynx helicopter, is only 249 miles per hour. But the Harrier can reach speeds up to 730 miles per hour. For the pilots, it's the ultimate thrill.
The Harrier is a blast to fly. It's one of the most difficult airplanes, which means that it takes the best pilots to fly it.
Harriers are flown by the top American and British pilots.
It's a thrill to fly it. I don't understand why every 10-year-old boy doesn't want to come and do the job I do.
The most experienced Harrier pilot in the world is U.S. Marine veteran Jack Jackson.
Well, when you walk out to the flight line to fly a Harrier, it's always a thrill, no matter how many times that I have done it, no matter how many times that you strap it on. It's just a wonderful, wonderful feeling, and I've enjoyed it immensely over the years.
Jackson has flown over 5,000 hours in Harriers, more than twice the hours of any other pilot in the world. When he first learned to fly the plane, back in 1971, the training was highly unorthodox.
We didn't have two-seaters back then. We didn't have simulators even. Your instructor was in a pickup truck sitting below, and I'll never forget it. The first time I got it up, I got up in the air and I went, "Okay, God, if you can get this down, I think I can handle the next one." And the brief was, if your instructor came up on the radio and said, "Throw out your wallet," that meant you were about to crash.
Jack Jackson is now a test pilot at Boeing, responsible for testing every new Harrier AV-8B.
This is the AV-8B. It's the second Harrier ever built, and we use it as a tech demonstrator here at Boeing. You look down the intake, and it's a huge engine. The engine is a thoroughbred. This airplane flies on the engine, very similar to conventional airplanes flying on the wingtips. If you look here, you've got auxiliary air doors, as we call them. A term that we use is aux air doors for auxiliary air. The auxiliary air is used in the hover, and it takes extra air in because the airplane is not moving forward to take it down the intake. Obviously, the next thing that you're probably curious about are the nozzles. In the cockpit, you may have seen a little lever about the size of my finger, and it's a black lever, and you move it back, and when you move it back, these nozzles swing down. This one here, and this one here, and there's two on the other side just like it. And that's how she hovers, because when the thrust is going this way, it's going like that. Good example, take a blow dryer when you dry your hair in the morning, push the blow dryer here, hair's gonna go this way, put it here, hair's gonna go that way. Pretty straightforward. I like this airplane far better than any airplane I've ever flown. And I've flown lots in my time. But the reason I like it, it's the difference, it's like a sports car. It just fits around you, it's maneuverable, and it can do so much. It can do all the conventional things, yet land on your backyard. So I like it.
For takeoff, the nozzles direct the thrust straight down. As the aircraft lifts off, Jackson rotates the nozzles to horizontal for forward flight. The red areas in this thermal image show the scorching hot exhaust gases. 24,000 pounds of thrust blast the entire weight of the 15,000-pound Harrier vertically into the air. To land the aircraft, Jackson approaches the landing area like a conventional jet. But then he rotates the jet nozzles so they point directly down.
The water is not flowing.
Once the Harrier is in hover mode, the wings provide no lift. The entire weight of the aircraft is balanced on the thrust from the 4 engine nozzles.
Because there's no wind moving over the wings, like a conventional airplane, it had to have an additional flight control. These flight controls are called puffer ducts. And they're right out here on the wingtips, and there's one in the nose, one on each wingtip, and one back in the tail. And when he moves those flight controls, these puffer ducts move and help the airplane move when it's in the hover. And that's how we hover it, and that's how you see the turns on the spots and the bows and the side to side.
In the thermal image, the puffer ducts show up as hot spots on the wingtips, nose, and tail. While it's hovering, the engine is at full power. To stop it from dangerously overheating, water is injected into the engine. With only 150 gallons of water on board, the Harrier can only hover for a maximum of 90 seconds. The largest Harrier force in the world belongs to the U.S. Marines. The Marines are on permanent standby to land thousands of troops anywhere in the world. This assault force of 3 ships is led by the USS Saipan. It carries 6 Harriers, capable of delivering awesome destructive power. The Marines are ready to launch an amphibious attack exercise just off the North Carolina coast. The Harrier pilots will provide close air support to the troops.
As we're called, we'll be sitting on the deck waiting to go, and if they need us, they'll launch us. And with 6 aircraft on board, we'll be able to keep 2 in the air pretty much constantly. So we can provide almost continuous close air support for the Marines as they're assaulting ashore.
BLT gunners, draw ammunition and proceed to station. Man all 25mm and 50 cal gunnery stations.
To get in as close to the shore as possible, the USS Saipan is a quarter of the size of a full-sized carrier. The flight deck is only 820 feet long, and there is just one plane that can take off from here, the Harrier jump jet. Although the Harrier can take off vertically, when it's fully armed and loaded with fuel, it needs a short runway. A few minutes later, amphibious landing craft are launched from the stern. They carry the first wave of Marines, whose task is to establish the beachhead. The Harriers fly in to wipe out key enemy positions and clear a path for the troops. One of the first to arrive with the ground troops is an experienced Harrier pilot who will be in radio contact with the pilots in the air. He will coordinate the air support.
305345. As an aviator, he's able to see and understand what we as pilots are doing as we come rolling in on a target. By the very nature of the mission, close air support, it means that we're going to be dropping live ordnance in close proximity to friendly troops.
The pilot instructs the ground troops to direct a laser beam onto the target, which the Harrier weapons lock onto.
600, 2 tanks in the open. Mike Golf. 635, 938.
Nine 52, continue.
Laser on! Laser firing! Laser firing!
Jump jets are extremely rugged. They can land almost anywhere.
The strength is that we can be forward deployed, we can land on roads, we can take just about any kind of fuel that you want to put in it. As long as we have somebody to put new bombs on our airplane, we'll take off again and be minutes from the fight instead of half an hour from the fight.
At the end of every mission, they face the challenge of landing on the carrier. To help them slow down, the pilots direct the Harrier nozzles forwards.
When you put the power up and you throw the nozzles forward, you slow down quite rapidly. You'll go from 500 knots to under 100 knots in just a few seconds. It kind of leaves you hanging in your straps, and you can definitely feel it.
The only way down is vertically onto a ship that is constantly moving.
But once you're in a steady state hover, the reaction control vents on the nose, wingtips, and tail of the airplane provide you some factor of stability while you're getting most of your thrust from the 4 main nozzle engines.
These Marine Top Guns have to land on the carrier up to 10 times a day. For these pilots, flying a Harrier is the pinnacle of aviation.
I can't imagine doing anything else. I can't believe I'm getting paid to do this. This is my office right here, so it's no, I can't. I really can't imagine doing anything else.
unique control system of the Harrier is the result of 50 years of development. Since the 1940s, designers around the world have been trying to make an aircraft that could take off using as short a runway as possible. During World War II, the German Luftwaffe attached rockets to their planes to reduce takeoff distance. After the war, the American military copied the idea. The great advantage was that these aircraft could take off even if their runways were destroyed. But they still needed a runway to land. The Ryan Company tried a new approach with a plane that was designed to take off and land on its tail. The Vertijet used all the thrust of the engine to blast it into the air, and then it tilted into position for conventional flight. To get it back on the ground, the pilot had to hook the aircraft onto a specially designed stand. This incredibly difficult maneuver was eventually considered far too impractical for a fighting machine. The first conventional aircraft that could take off and land vertically was the Bell X-14. It had two jet engines in its nose, and the thrust was deflected downwards to keep it in the air. It was underpowered and could barely lift its own weight. The designers experimented with all types of engine configuration. The Hummingbird's problem was that its lift system was huge. It took up the entire fuselage and was far too heavy to be practical. Across the Atlantic, British engineers experimented with their flying bedstead, designed and built at the Rolls-Royce Aero Engine Company.
The flying bedstead is powered by two Rolls-Royce Nene engines, set horizontally in opposition, one on either end of the framework. The jets from these engines are ducted through 90 degrees so that both engines discharge vertically downward under the center of gravity.
The bedstead could support its own weight and be controlled. The British were so encouraged by their success that they went on to build the Short's SC-1. In this prototype, there were 5 engines, 4 for vertical lift and 1 for forward flight. But the SC-1 was still too heavy. It couldn't carry weapons or fly very fast. The French went one step further and produced the Balzac, a vertical takeoff and landing plane with 9 engines. The Balzac was designed to go supersonic, but it never did. This monster of a jet was difficult to handle, and it had 2 fatal crashes before it was abandoned. Everybody had tried. Everybody had failed. Finally, it was an independent French engineer who came up with an idea that was to lead to a breakthrough in vertical flight. Michel Vibo's brilliant concept was to use just 1 engine for both lift and forward flight. At first, his radical plans were rejected by governments around the world. But then an English engineer, Gordon Lewis, realized their potential.
If you imagine 4 nozzles pointed downwards or rearwards, you've got some sort of picture of what the Vibo machine consisted of. Together with my colleagues, we realized that although it was a quite horrendously complicated piece of machinery, it embodied a very, very important principle. The engine arrangement that he devised could direct the thrust downwards for vertical rising or descent, and horizontally for normal propulsion, or anywhere in between.
Vibo had envisaged one engine mechanically driving 4 individual fans. Gordon Lewis simplified Vibo's design. He removed the fans and directed the gases through 2 movable nozzles. Aircraft designer Ralph Hooper wanted to create more lift and greater stability, so he directed the gases through 4 nozzles.
After, I think, 3 attempts to make an aeroplane out of the engine had failed, I was gazing at the 3-view print of this thing rather unhappily, wondering whether to drop it and go back to what I was supposed to be doing, when the obvious idea arose of splitting the back end a similar way to the front of the engine. Like all ideas, it's obvious once you've had it, but it comes as a great relief when it first arrived.
Realizing he'd cracked the problem, Hooper moved on to design the airframe to house the engine and nozzles. Working together, Hooper and Lewis finally produced the first prototype Harrier. The key to the Harrier's revolutionary design was the Pegasus, the first single engine powerful enough to lift a full-size military airplane.
About March 1958, we had something that looked as though it might conceivably work.
But the new engine was far from reliable.
The firemen absolutely loved it, because in those days the engine used to catch fire every time you closed it down.
The chief test pilot, Bill Bedford, was asked to hover the Harrier for the very first time. In the early tests, the aircraft was tethered, and the engine produced barely enough thrust to lift it off the ground.
The first hover tests were really amusing, I suppose, looking back on it, because the engine thrust was really inadequate. So the aircraft had to be stripped of all non-essentials. There was even a thought that Bill Bedford could shed a bit of weight himself.
The prototype also proved very difficult to control. When it was finally unleashed from its tethers, Gordon Lewis and Ralph Hooper were particularly nervous.
I was petrified with fear and anxiety. When you're aware of the deficiencies and you see this chap poised, relying absolutely totally on the engine functioning properly, you are slightly nervous.
I was quite glad when the pilot throttled back and put it back on the ground again. Nevertheless, it worked.
In just 3 years from the first drawings, the Harrier was born. Top test pilot John Farley found it difficult to control.
The aeroplane at the beginning required more skill to fly it than I had, and I don't like leaning on luck, and every time I got out of the thing, I thought, I'm glad I didn't break it.
Near the end of its display, something goes wrong.
At first, the Harrier was unpredictable.
Bad luck for Britain.
Some of its unique design characteristics caused serious handling problems.
One of them was that if you didn't keep the airplane pointing very accurately into the wind, called zero side slip, during the accelerating and decelerating transitions, if one wing was going a bit in front of the other, then that wing generated a bit more aerodynamics, and the aircraft could roll. It was an awkward, nasty little aeroplane at that time, but the vision of what was on offer was just mind-boggling. And the rest was just detail, which one knew the scientists and the engineers would get sorted out.
The problems were overcome. Soon, John Farley became a master at demonstrating the incredible Harrier.
There was a day in 1969 when I thought we really did have an aeroplane. An aeroplane not that one need be afraid of, you might be going to break, but an airplane was good and do what it was supposed to do and was a really practical fighting machine.
In 1969, the Soviet Union was flying supersonic MiG-21s. The British Air Force wanted fighter jets that could, at the very least, match the MiGs for speed. They were reluctant to invest in the Harrier, which was incapable of flying supersonic. But one fighting force, the U.S. Marines, was ready to push the Harrier into action. During the Korean and Vietnam Wars, it had taken too long for air support to reach and protect frontline troops. The Marines needed a vertical flight, or V-stall plane. Harriers didn't need runways and would be able to operate much closer to the troops.
The Marine Corps had been looking for a V-stall aircraft for a long time. A couple of aviators went over to fly it and came home and convinced their boss that this might be it.
The Marines wanted to tailor the Harrier for their own specialized needs.
Performance wasn't everything that we would like. And when I came back and announced that to my boss, he said, "Ed, you don't understand. The airplane's perfect. And after we get it, we'll modify it." And that was the course they took.
In 1971, Britain produced 100 Harriers for the U.S. Marines. When they were delivered, they were put straight into service.
I think they were so concerned with this aircraft that they put their very best pilots on it. I mean, something like 25% of that first squadron were actually graduate test pilots. They had 0 accidents for the whole of the first 2 years, absolutely 0. And so they started to post youngsters to it, in particular helicopter pilots, because this thing hovered, and so you put helicopter pilots in it, don't you? Well, the helicopter pilots had no trouble with the hovering, but they were bumping into hills at 550 knots at low level and so on, because they just hadn't got the sort of currency for fast jets.
Between 1974 and 1978, there were 19 crashes. It was at the height of the Cold War when the British realized that the Harrier could be useful to support their frontline troops in Germany. The aircraft could hide in forests and take off vertically from small clearings. The Harrier soon became an essential part of NATO defense. But the first time it was used in action was in a war 8,000 miles from Europe. By the early 1970s, military cutbacks meant that the British Royal Navy couldn't afford to replace their huge, aging carriers, designed for heavy fighter jets. But Harriers could take off from short decks and allowed the Navy to build much smaller and cheaper carriers. A new version of the Harrier, the Sea Harrier, designed for air-to-air combat, became the first Harrier to engage in real warfare. In 1982, Argentina invaded the British Falkland Islands in the South Atlantic. Britain's task force, sent to retake the islands, faced long odds. A naval invasion 8,000 miles from home. Just 28 Harriers faced a 200-strong Argentinian Air Force, including supersonic Mirage fighters. But the British had the element of surprise. The Argentinians were unsure what to expect from the Harrier.
All the articles that have been published about us using vector thrust in the air and stopping and jumping sideways were great because it scared the hell out of the Argentines, and they were very, very cautious. They really didn't want to get into a fight with us.
Even before the British could unload their troop carriers, the Argentinians attacked.
On the first day, they sent their Mirage 3 squadrons out to have a go at us, and we shot down 3 of those for no losses. And after that, they referred to us as the Black Death, the Muerte Negra.
On June 8th, the British forces suffered a terrible blow when one of their troop ships was bombed by the Argentinian Air Force. Harrier pilot David Morgan was scrambled to intercept the enemy planes.
I sat up at 10,000 feet, watching helplessly as the helicopters were in there trying to rescue them, and lifeboats rowing ashore, feeling pretty mad. I looked down and saw an A4 Skyhawk running in to attack a small landing craft, and screamed to my number 2, A4 attacking the boat, dived in.
As he closed in, Morgan realized there was more than one A4 Skyhawk attacking the boat.
The second one hit the landing craft with a bomb on the back end, which made me very, very angry. And at this stage, he was going to die. There was no doubt about it. I was going to have him. I locked the missile onto him and fired it. I think he saw the missile coming off the rails and hit him at about a mile range and just blew the back end of the aircraft off completely.
That day, David Morgan and his wingman shot down 3 Skyhawks. By the end of the conflict, the British Harriers had shot down 21 Argentinian aircraft. Not a single Harrier was lost in air-to-air combat.
The tactics are designed to confuse the enemy and to sucker them into thinking you're doing one thing when in fact you're not. And it worked.
The Harrier pilots had won. David Morgan survived the war, in spite of his Harrier being hit in the tail. The Harrier still plays a critical role in the armed forces. Today, the Royal Air Force and Royal Navy have a single combined Harrier strike force. Here in Scotland, they are on a training exercise to practice vertical landing and takeoff in any place in all conditions.
Poison 1, check flaps, clear takeoff the strip, wind 03010.
RAF pilot Pat Voigt is flying the latest Harrier on a practice bombing run.
It's a thrill to fly it, as well as being very, very operationally capable. It can deliver very, very accurately weapons against targets.
The RAF Harrier's primary role is ground attack.
It's a question, first of all, of identifying the target and then getting the aeroplane into the right position to actually simulate dropping the bombs in the correct place. If you imagine standing on a 100-foot building and looking about 3 miles away, we're going to cover that sort of distance in about 25 seconds. We've got to pinpoint the target that we've been given and actually the particular impact point that we've been given as well within the next 10 seconds. And you're traveling very, very fast. It might not be a huge target. It really does concentrate the mind flying at 100 foot and going at those sort of speeds.
The British strike force combines the air-to-air agility of the Sea Harrier with the pinpoint accuracy of the RAF ground attack Harrier. Like the U.S. Marines, the British strike force is on standby to be deployed anywhere in the world. The Pegasus engine, originally designed 40 years ago, still powers every Harrier. Each engine is still hand-built in the same factory in England. With new metals and ceramic materials, the engineers have been able to improve the efficiency of the Pegasus and double its power. Completed engines are shipped to Boeing's assembly facility in St. Louis, Missouri, where they are installed in the Harrier airframe. Today's Harrier II has the same basic design with the 4 adjustable nozzles, but the airframe has been considerably modified.
The original Harriers, the Harrier I, that was a result of Rolls-Royce and then Hawker Siddeley, was an all-metal construction. When we went to the Harrier II, went to more composite, modern technology. The wing and the forward fuselage is mostly built out of composite materials, and you get weight advantages with similar type strength in that construction.
With added power and a lighter body, the Harrier II is able to carry more armaments than ever before. During the Gulf War, the U.S. Marines deployed 88 Harriers, which were able to operate from much closer to the front line than conventional bombers. British Harriers have also seen action in the skies above northern Iraq, Kosovo, and Bosnia. The Harrier is still the only proven vertical takeoff and landing aircraft in the world.